Hello. Today we're going to be looking at writing quadratics in vertex form. And this is an example of what a vertex form looks like for a quadratic, and you should definitely add this to your notes. But the whole purpose of us writing it like this is because you can see inside this quadratic we can pick out the vertex for the parabola we're trying to graph. Okay, so if you need to, please pause this video and add this to your notes. I'm going to move on to the next slide. So the directions here ask us to convert the quadratics that we have given in numbers 1 and 2. They're currently in standard form. We want to turn them into vertex form. And so my goal here is to take these front two numbers and turn them into some quantity squared. So I want to make this a perfect trinomial square again, and our complete the square work will come into play one more time. So x squared plus 6x, and I'm going to leave a space here for my perfect square. I'm going to stick that negative 12 out the back. That's going to help come part of our k. And so I do my complete the square work, and if you remember, that's where we take our 6, we divide it by 2, and we square it. Well, 6 divided by 2 is 3, and 3 squared gives me 9, so I do a plus 9 here. And because I added a 9 there, I need to keep this equation balanced. And so to undo that, instead of adding 9 on the left, what I'm going to do is I'm going to subtract a 9 on the end of this. I don't want any numbers with my y. Notice that y is by itself here. So a plus 9 minus 9 in this equation will become 0. It's like adding nothing, so nothing changes. But this negative 12 and negative 9 are going to become part of my k. So to write my final answer, y is equal to, and this set of parentheses should now become some quantity squared. So we get x plus 3 quantity squared, still minus, and at the end it's 21. And I can go even further on this, and I should be able to tell you that the vertex for this is negative 3 comma negative 21. Okay, notice that inside the parentheses you use the opposite sign, and then outside the parentheses you use the same sign. Okay, so let's try this now for number 2. Same principles here. We're going to do our complete the square work for my first 2. That negative 3 is going to work to become part of my k. But that 6 out front of the x squared was always an issue for us. We couldn't do any complete the square work unless that was gone. So what I'm going to do is I'm going to distribute or factor out a common factor of 6. So I get x squared minus 8x space and then that negative 3. So we do our complete the square work. We take our b, which is negative 8, divide by 2, and square it. So we get negative 4 quantity squared, which is 16. So I'm going to put a plus 16 here. Now, not so fast on throwing a negative 16 at the end, though, because if I were to distribute this back together, there's my 6x squared, there's my negative 48x like we wanted. This number here isn't a 16, it is a 6 times 16, in which we get 96 for those, okay, and still minus 3 at the end. So in order to undo a plus 96, we're actually going to subtract 96 at the end there, because again that is the number 6 times 16. All right, let's continue on. Get my orange out. All right, so y equals, we still have that 6 out front. That set of parentheses should turn into a perfect trinomial square. And x, and remember it's the same as this number right here, so minus 4 quantity squared. Negative 4 squared is 16. Negative 4 times 2 is negative 8. And then over at the end here for our k, we have negative 3 minus 96 more, so that gets me a negative 99. And so you can see our vertex is at positive 4 comma negative 99 for this particular equation. And we are done.